So, what exactly are Jupiter-mass binary objects, or jumbos for short? Imagine two Jupiter-sized objects orbiting each other, like a binary star system but with much lower mass. Unlike typical planets, they do not orbit a star. Jumbos are pairs of objects that are not quite stars and not quite planets but with masses similar to Jupiter, orbiting each other at much greater distances than Jupiter is to the Sun. Jumbos were first proposed as a theoretical possibility, but recent advancements in observational techniques have started to reveal their existence. Astronomers using the near-infrared camera on the Webb Space Telescope scanned a section of the Orion Nebula on the hunt for low-mass objects. What they found surprised them. Thought to be a rare occurrence, it turns out that astronomers found 42 pairs of jumbos orbiting each other in just a small section of the Orion Nebula. The binary pairs are gravitationally bound to each other by a distance anywhere between 28 to 384 astronomical units. For comparison, the orbit of Pluto is about 40 astronomical units from the Sun, making some of these separations much larger than Pluto's orbit. Jumbos have masses between approximately 0.7 and 13 times that of Jupiter. They are likely composed primarily of hydrogen and helium, similar to gas giant planets, with a dense, solid core. These newly discovered binary objects were found in a young star-forming region of the Orion Nebula. The detection in this environment suggests the jumbos are very young, likely only about 1 million years old. The discovery of these objects is significant because they challenge existing theories of star and planet formation. Scientists are exploring how these massive, free-floating binary systems form and how they came to be ejected from any parent star systems. The formation of jumbos is still a topic of ongoing research. They could form through the fragmentation of a collapsing gas cloud, similar to how binary stars form. Alternatively, they might form within a protoplanetary disk and then, ejected from their original system to become free-floating objects. Another theory is that the radiation from a more massive star stripped away some of the material from the jumbo, while the remaining material got compressed, gradually being reshaped between the size of a low-mass star and a brown dwarf. Binaries were found to have the minimal proper motion compared to the rest of the nebula, suggesting that the object is either moving slowly relative to us or is at a great distance, making its motion less noticeable. The most surprising thing about Jupiter-mass binary objects, or jumbos, is that they exist at all, challenging our fundamental theories of star and planet formation.